I'm Dennis Berg, and welcome to the Cisco Security Suite demo. Attackers are increasingly sophisticated in circumventing perimeter defenses to target data and applications at the heart of the business. To meet this challenge, many security teams employ a big data approach for security intelligence using Splunk Enterprise, the industry-leading platform for machine data. Splunk is unique in its ability to collect, correlate, and analyze massive volumes of data across a multitude of sources in real time. In this demo, you'll see how the combination of Splunk and Cisco security products enable you to quickly obtain visibility across multiple Cisco security platforms before an attack happens, quickly detect new threats and respond during an attack, and quickly discover if other assets were infected by performing a forensics investigation after the attack, all by connecting the dots between security information coming from a variety of Cisco security products. Having a complete view of your organization's security posture before an attack drastically reduces the time to respond to a cyber attack. Splunk and Cisco have collaborated to deliver out-of-the-box visibility across a range of Cisco security platforms via the free Cisco Security app from Splunk Enterprise. Splunk Cisco Security provides a consolidated view across your entire Cisco security environment with the ability to drill down into specific areas including email security, using email from Cisco's Email Security Appliance, or ESA, web security, which categorizes web traffic coming from your proxy via Cisco's Web Security Appliance, or WSA, network security, which presents data from Cisco ASA, PICs, and FWSM firewalls, plus Cisco Security SourceFire, IPS, and malware detection data, and identity services, which presents contextual user and device information from Cisco's security policy management platform known as Identity Services Engine, or simply put, ICE. From the Cisco Security Suite, you can set up a range of triggered alerts for key events and thresholds leveraging data from multiple security relevant sources. For example, often one of the biggest security challenges involves infected computers that fly in under the radar of traditional antivirus software. Advanced Malware Protection, commonly called AMP, is a SourceFire product that continually analyzes endpoint data for threats and can retrospectively identify malware that has already breached your security. Using Splunk, it's possible to combine SourceFire AMP malware detection data with user and device information from ICE to determine whether an infected device belongs to someone from a high-risk population and then to classify this as a critical event. So let's see this in action. Let's say that AMP has identified an infected endpoint and ICE data reveals that the user is an IT admin, which we previously classified as a critical identity group given their broad network privileges and access levels. We see this here under triggered alerts. You've received an alert for AMP user infection text with a severity of high. Let's view those results. In addition to this alert, Joseph has had a number of threats reported. Let's look at him in more detail. This is Joseph Martinez, and according to the ICE information, he's an IT admin based in San Jose. He has 3 devices. While his laptop and phone are compliant, it appears that his iPad is in an unknown compliant state and logging in from Hong Kong. Yikes, we have an infected device coming from Hong Kong with virtually unrestricted network access. I want to quarantine him immediately. The good news is that Splunk and Cisco have built a number of bidirectional integration layers using ICE APIs and PXGrid. After identifying a threat based on event data in Splunk, it takes just a single click to use Cisco ICE to initiate a network mitigation action on a user or device. For the purposes of this demo, we're going to demonstrate having ICE move this user into network quarantine by clicking Quarantine. I'll do a quick refresh and we'll see that Joseph is now in a locked status. Now that the immediate attack is addressed, we move into the after phase. We need to perform a forensics investigation to determine the extent of the attack and take additional action. From this user profile page with ICE data, I can also see Joseph's browsing history and network traffic leveraging data from Cisco ASA and WSA. There seems to be a lot of communication with one particular IP address here, 201.3.126.5. It also appears that this IP address belongs to the URL domtar by RU, a Russian website which is likely a malicious site. I'll hand this IP over to my WSA admin and ask them to investigate. There's also significant disparity between the 2 counts of communication. It looks like there's a lot more going on between these machines than just browser traffic. We'll investigate that in just a moment. But first, let's do some general research to see who else is interacting with a Russian website. This dashboard enables you to search across all Cisco devices. So let's take a quick look to investigate this IP. In the past 4 hours, 2 types of traffic have been directed to this IP. It looks like general network data as well as ASA information. Let's start by looking at the web traffic. Here we see all the data captured from our WSA appliance, all of the raw data. Splunk has already extracted the fields and their values, which we see on the far left. If I mouse over the field username, I can see that there's been a lot of traffic from different users. Normally I create a report and verify that the devices these users are on are in compliance and not infected. For now, let's go back to our generic network data and dig a little bit deeper. In this instance, I see generic network data with ICE user and device information appended to it. And it looks pretty strange. There's no reason why a network printer should be trying to communicate with a Russian website. Likely it's another device that is spoofing itself in order to get around the antivirus malware that's automatically pushed to every computer. Again, I'll use my one-click integration with ICE to prompt ICE to quarantine the source IP. We can then inspect this endpoint and perform a scan or a full wipe. Finally, let's take steps to prevent future attacks. Since the attacker gained access via Joseph's iPad, which is out of compliance, let's wrap up this demo by running a quick report of users who are not compliant with their endpoint security posture requirements. In this example, Joseph was a canary in a coal mine. His single infected iPad was an indicator of a widespread attack underway. As you saw in this demo, Splunk delivers security intelligence before, during, and after an attack. Because we've unified visibility across security and other events on the network before the attack, when AMP flagged the infected device, we were able to immediately neutralize the threat during the attack. After addressing the initial issue, we then performed a detailed forensic investigation, leveraging a range of security-relevant data sources in a matter of minutes, not hours. This is just the tip of the iceberg of what's possible with Splunk. Splunk is a highly flexible, extensible platform. You can easily build on the out-of-the-box functionality of the Cisco Security Suite to add custom reports and integrate additional data from any source in your environment. To learn more about how Splunk can help you maximize the value of Cisco and other security investments, check out the Cisco Security Suite on apps.splunk.com.